Good afternoon, and thank you for joining this webinar. It's on practical tips for managing and minimising calf pneumonia. Today we have speaking Chloe Rodriguez, the Animal Welfare Specialist at Galebreaker, and Kat Hart, the Vet and Youngstock Specialist at the George Vet Group. So on the agenda for today, we have housing and hygiene hints and tips. That is Kat's department, and then Chloe is going to be talking about housing essentials, focusing on ventilation and positive pressure tube systems. We'll then follow with some questions. If you do have any questions, please leave them in the chat. I'm going to pass it on to Chloe and Kat just to give a brief introduction for themselves, and then we shall get started. So, Chloe.
Hi, I'm Chloe, Animal Welfare Specialist at Galebreaker. For those of you who don't know, Galebreaker specialise in agricultural ventilation. We've been going for 40 years and we sell, design and manufacture and distribute worldwide. Very much everyone knows us for our green mesh and weather protection, and everyone knows it as the Galebreaker. But in the last 20 years, we've really focused on side curtains, ridges, and really optimizing natural ventilation. Also smart farm building control. And then in the last 5 years, we've supplemented with positive pressure tube ventilation. And then that's kind of led us on to our animal welfare department, where actually we're putting animals first with building optimization. And that's where I joined 3 years ago on my placement year to really look at the benefits of ventilation and housing on animal health, welfare and production. And then I went back to finish my studies and I've rejoined Galebreaker permanently, leading their animal welfare team.
Hello there, I'm Kat Hart. I work at the George Farm Vets, based in Malmesbury, but covering a lot of Gloucestershire and Wiltshire. And I also do Youngstock consultancy throughout the UK mainly. So a bit about me. I'm a dairy farmer's daughter. Makes me feel very old there, that top picture, but we had a pedigree Holstein herd that we showed around the show circuit quite a bit. So that was really what got me into the calf rearing side of things, I guess, feeding the calves before and after school and doing that kind of a thing alongside the studies. Then went off to vet school. After vet school, my first job was at the George, so I'm still there, what are we now, 13, 14 years later. But along the way, I've got two boys, feral farm boys that came along, and then the picture of the Anguses there. So we've got a herd of red and black Anguses. So during COVID back in 2020, I was off on maternity leave and getting bored, I suppose. So filled in lots of applications and managed to get a county council tenancy. So trying to do the whole regenerative thing, which is another area that I'm really passionate about, how we can farm more sustainably. So we run there the Angus, some sheep, some bees, and also a no-dig market garden. But still, you know, the dairy Youngstock is my big passion and what I spend most of my working life doing now, whether it is ventilation work, as in the picture there with lots of smoke bombs, nutrition, or the more sort of traditional veterinary role of how we can control disease. So what am I going to cover today? So yeah, I'm going to go through a bit on the housing and a lot on hygiene and some hints and tips. So trying to make it really practical and applicable to all systems is the aim. So I think this is interesting whenever you start to look at something looking back to where have we come from. I think we can all say that there is still place to improve. So you go back and find some quotes from the 1980s and it says that 50% do not ventilate adequately. And then you jumped forward 20 years, something from AHDB that says at best 80% of calf buildings will ventilate some of the time. Obviously weather conditions are very variable. So where are we now? Well, we're at 2024, so we're 20 years on from that, and I think there's still, as a nation, there is still massively areas to improve on. Obviously, at the moment, we've got the calf housing grant sort of coming to that end of this first window. So whether that will make a big jump in these figures, it will be interesting to see. So whenever I think about calf house building, there are 5 points I always look at, and whether this is sort of looking at existing buildings and how we can make small changes to those, or similarly if we're going to create a new building. So obviously we've got the fresh air and air speed, but I'm not going to cover that. I'm going to leave those tricky topics to Chloe for later. But I'm going to jump in there with my point 3, which is moisture, and then cover some on temperature and how cleanliness is really important. So I'm sure it's not just disorganised me, but I'm sure we've all had to put wet clothes on at times when our laundry hasn't quite been as it wanted to be, or equally if you've been in the weather that we've had the last few days and your coat's not been as waterproof as you thought they were, we end up having wet clothes and they do feel cold. So this is why in the lower critical temperature actually increases. So a nice practical thing I often do when I'm out on farm is get a litre of water in a jug and just pour it on the floor. And this roughly covers a metre squared on the floor. So what you can see is quite easily then a small amount of water actually covers quite a large space within a calf shed. And then we have to think about how much energy that's going to take to evaporate that into the air. So you can work it out, and it says that it's 3.4 hours of a calf's energy to do that. But also we've then got to think that we've got this wetter, humid air in the calf shed. So what can that do? Well, that will increase the lifespan of any viruses in that airspace. But also, if it is on the floor, it will allow those bacteria and those particularly single-celled pathogens, so crypto being a key one for this age group, to spread between pens a lot easier, to be able to swim around and spread throughout the calf shed. So moisture is one of our key things that we really want to control as much as we can. Obviously, the weather has been a challenge these last few days, particularly with the floods going around. So hopefully that's not affected too many of you guys. But also then we've got the temperature. And there are quite a few different sort of facts and figures on this slide, but I think it is quite an important one to get our head around. I think the message of how during the winter we want to either feed more or put coats on or put heaters in, I think that message has got across really well, but it's why we need to do that. So hopefully by the end of this slide and the next slide, you might understand that a bit more. So each calf has what's known as a lower critical temperature. So that is when it goes below that, they're going to use their own energy to keep warm. Obviously, as the farmer and the vet, we want them to be using their energy to grow, to increase their immune system, and to progress as a calf. So as soon as they're using their energy to keep warm, we're going to lose a share of that. And this does depend on genetics to a certain extent. So we've got the typical Holstein calf here, it's approximately 15 degrees. If we go for the more native beef or crossbred beef animal, we're thinking it's more like 10 degrees compared to the Jersey, which is quite high sort of TLC type of a calf, and they're thinking Wagyus are more like this, they're more up at 20 degrees. So this is this key temperature that when the air around the calf gets below that, they use their energy to keep warm. But there are things that can worsen this. So as I said, with moisture, putting them in a damp bed, that will increase it a further 6 degrees, or if you put them in a draft. So we haven't covered the wind speed bit yet, but a draft to me is anything over that 2 meters per second, and this will increase it by 9 degrees. So now any day under 24 degrees, then the calf will be using its own energy to keep warm. If we have both of those things, so we have the damp bed and we've got a draft, we're up at nearly 30 degrees and they're already using a share of this energy to keep themselves warm. So really what we can do practically as the farmer and the vet is to prevent those drafts and those wet beds from happening, and to be aware that if you've got that Holstein calf, maybe 15 degrees is this number we need to think about when it gets colder than that. So what can we do? We are going to get temperatures colder than that. I think you'll definitely agree. It's not a particularly chilly morning today, but it's definitely less than 15. So there are three sort of strategies that we commonly use. There's the top picture, which is the coat picture. This has really taken hold, I would say, in the last 10 years. Massively, a lot of farms have these. They can work okay. Some data coming through now is questioning them a bit, and we do have to particularly be aware of the way that they can mask disease and spread disease if we aren't really washing those coats at really warm temperatures. So really we want to be doing over 60 degrees and ideally resting them quite a long time between calves. The second picture there is of a jersey, so we've gone for the double option of a heat lamp and a coat. But heaters are becoming more common in calf sheds as another way of just getting that energy into that space. If we're going more for the sort of quartz linear or like the patio heaters, we are then trying to heat the surface that it's in contact with, not the air, because as we'll cover later, we want that air to be changing quite quickly within that calf shed. But that is definitely something to consider, either retrofitting into sheds or definitely if you're planning any new sheds, how we can add heaters into that space. And then there is the one of just feeding more concentrate of milk powder. So consistency is still key. We will go into nutrition a bit later, but really making sure that there's enough calories in that milk. So we're either feeding higher volumes or consistently a higher quality of milk powder or quantity of milk powder. So that's another option of just how we can add more energy into the system during those winter months. Okay, and then on to cleaning. So I'm sure it's not just me and the farms I visit, but crypto is really hard to manage and is really hard in all, particularly all year round systems, but equally at the end of blocks. It starts to create its havoc that it brings along with it. And you say, well, why are we discussing this in a pneumonia webinar? But often after a period of scour, then 2 to 3 weeks later, we will then get a period of pneumonia within that group. So it is important, particularly from a housing point of view, that we think of this holistically with all areas covered. So we do still need that general clean out and making sure we try and achieve that all in, all out system. If we're in groups, definitely. But even when we're still within maybe paired pens, trying to do sections of a shed at a time. So we do that general cleaning out, so trying to remove as much organic material as we can. And then we think of specific disinfectants. All of these will generally only work without any organic matter. So actually that general clean out, we should be including some type of steam cleaning or at least pressure washing. That does increase the moisture in the air, which we've obviously said is a challenge, but trying to, particularly if we've got crypto on farm, making sure that we are trying to minimize that level of challenge wherever possible. If you try and think holistically and step back a bit, you go into like the areas of the pig and poultry world, which obviously cocci and the single cell parasite is a challenge to them. They will say, oh, it's relatively easy, you just use flamethrowers. I'm not that confident to be suggesting that on farm, to be honest, with all the straw that's around in these sheds. Definitely, maybe if you are a block carver and you empty the shed completely, it might be worth a try, but it's not something that I routinely use or advise on. But it is just something to think about, how difficult these crypto oocytes are to get rid of. So the option, which unfortunately is often overlooked, is probably the simplest and cheapest, which is time and UV light. So if we are on a hutch outdoor system, then obviously UV light can be just removing those hutches and letting the UV light get into it, hopefully on these sunny days, which seem a long distant memory already. But even within a shed system, just having the time to rest and fully dry out is really key, and that will kill quite a high proportion of the oocytes within the environment. But really, we are looking for a 2-week rest period, which when you're talking to an all year round calving farm is quite hard to logistically manage. But if we can achieve it, it will massively help. And then as a practical thing, just to remember, don't forget the water and feed troughs. Make sure they're fully disinfected and cleaned between calves particularly. So hopefully that's that between batch cleaning, but also what's becoming more and more talked about is a once a year sort of deep clean or spring clean, often in the summer, but where we totally empty the shed. So obviously if you're a block, you already have this system in place, which is I think why crypto is has less of an impact on you. Whereas for an all year round farm, actually thinking, yes, we're going to empty that shed completely for about 2 to 3 weeks and fully deep clean everything. You can go through the fresh air, the air speed, and actually some cases outside at certain times of the year will be better. We think about moisture and temperature, which is why probably it is more of a summer thing. We could house them outside. We could use tarpaulins between gates or bales. That can work just to get a deep clean within the shed. Again, really making sure all equipment is cleaned and then trying to be as careful as we can of what we're reintroducing into that shed. So ideas of foot dips and limiting the time that the calves are with the cows. There is some more work coming out on that, particularly on crypto, how much is spread between the mum and the calf. So we're not quite sure on that, but it is quite sensible that we want to limit that exposure as much as possible. Obviously, colostrum is different, but that sort of more touching with the cow wherever we can, trying to limit that. So that's a quick whiz through the 3 points I'm going to cover from the moisture, temperature and easy to clean from shed. So now on to more of the sort of hints and tips of what I commonly advise. So the key thing for me is to try and think holistically on how we can improve the resilience of this calf. So whether that be through nutrition and or immunity. We've also got the idea of stocking density, in that if we can just lower the amount of calves per metre squared of the space, that will massively help all diseases. The idea of age range will go into a bit more detail. We've got the idea of drafts as well, as we said, with moisture and drafts, just how we can control that temperature, which I think Chloe will touch on. We've touched on hygiene already. And then it is that time of year that if we are monitoring temperatures, we've got to have a plan. So whether that is coats are already on, whether that is thinking about, do we need to get some heaters? Have we got the electric sockets to put heaters in? Or are we just going to feed more milk? And how are we going to do that consistently? And then the idea of how we can rest pens or paint pens maybe as a other way of changing those surfaces in this deep cleaning idea. So as a vet, obviously I can't do a talk on pneumonia without discussing vaccines, and it is a way to improve that calf resilience against it. So there are lots available, and please speak to your vets whether you want samples taken. We can do swabs or bloods, depending on which age group and which sort of problems you seem to be getting. But they do sort of group into two main groups. So we've got the pre-weaning problem. And generally, for those calves, we need the intranasal vaccines. So these are the vaccines that are squirted up the nose at that first. Some are available from the first day, some are available from day 7, day 9, and they kick in really quickly. So they are working within those nasal cavities to try and stop the viruses before they get into the body. And they're not affected by how much colostrum or maternal antibodies are there, so they kick in really quickly. And then we've got this different problem group, which is that post-weaning pneumonia group. And for those, often the intranasals are starting to wear off at this point. So we can then go in with injectables. Often you need 2 of these injections at that 3 to 4 weeks apart. And there are lots on the market depending on what problems you get on farm. So they're the 2 rough groups, and some people need one of those and some people benefit from having both of those groups of vaccines on farm. So that's where I'd start thinking about just increasing that vaccinated resilience of the calf. And then you've got nutrition. Which we have touched on, but making sure that it's really palatable. Calves should be really driven to drink a lot of milk, Easily digestible, particularly in that first 4 weeks of life. Really, we're looking for dairy-only protein sources, and that high quality of powder, making sure that, you know, it is a high dairy source, that the fats in there are as digestible as possible with those good quality cocoa and palm oil fats. So we're looking at roughly that kilo of milk powder a day. You could use the calculators to go through what weights and, you know, gains you're wanting, what temperatures you're hitting, what milk powder you are using, and it will work out what you need to be feeding each day. But equally, when we've got that figure, is making sure we get up to that figure on the feeding curve as quickly as possible, but we still get that really, really gradual wean. So whenever we're feeding more of these accelerated feeding programs, so more than sort of 4 to 6 litres of milk, we really need a gradual wean over that 2 to 3 weeks. Otherwise, we're just going to get a weaning crash later. So to touch on stocking density, if you want to pin me down to some figures, I say that 2.5 is really what we're looking at. If we've got a shed already up and we are dealing with sort of high numbers of calves, whether that is through the block or whether that is just how the you know, cow fertility has happened. Unfortunately, we can't guarantee we're going to get this many calves every single day of the year. We can work to 2 meters squared, but we have to really, really focus on hygiene and often have expectations of diseases we are going to get. So sheds will vary into what stocking density they will hold, but really it's the 2.5 to 3 meters squared we should be aiming at. And then animal grouping. This is often something that maybe isn't particularly thought about when you're first putting up a shed, but really, really important, particularly in that pre-weaning age. Again, more likely to be thinking from a scour point of view originally. So you want calves within that 10 to 14 days of age. After that, they will continue on quite well with life, but will be excreting a lot of those pathogens that then if you put a newborn calf into that pen will suffer quite a lot because of that extra disease challenge. So from a scour point of view, we're really thinking of that less than 2 weeks age range within pens, but then we've got to think about that wider air space. So really trying to divide off the pre-weaned calves from the post-weaned. This can be stretched sometimes with smaller herds, and some people have them weaning and you want to lessen the stresses, so we can easily stretch it to sort of 4 months. But if we're stretching much beyond there, this is really where those injectable vaccines have a place. Some people are trying to divide air spaces within a shed, so putting sort of plastic curtains and things. So that can be thought about in how we are grouping these animals, both within a pen, but also within the airspace. So just, I guess, going back to nutrition a little bit there, is making sure that what we are feeding them, we've got this quality product, we are spending a lot on this tonnage of milk powder, but we want to be feeding it in the most efficient way. So this is where actually cleanliness comes into the feeding equipment as well as the housing. So we don't want to be feeding a bacterial soup. And this is particularly important with the colostrum because that but we don't want the pathogens to do that. So making sure that everything is as clean as possible. And often farmers will say, oh, you know, yogurt is good. Yogurt is quite specific, the bacteria they are putting in, and quite controlled, whereas I think you can see in some of these pictures that isn't what's actually happening. So, you know, really good. We can do hot water temperature and elbow grease. That's still sort of the most option that most farmers go for. We can go down the route, but making sure we have really good contact time, really good drying is equally as important. So we've got racks for this to get it up off the floor, to get everything draining and drying. And then finally, just finishing off, I guess, we can do all the calculations we want with how we're going to feed these calves, but making sure they can actually access it. So obviously with milk, that's probably a bit easier and more obvious, but when it comes to maybe the cake and straw systems in the pictures below, making sure that they're not just pushing that away. And if we are going more onto a TMR system, again, making sure that those smaller calves can still reach all the food. Don't forget water. It's often something and actually they're still a small drinker. And then, yeah, we're still thinking of that fecal oral spread. So actually the idea of, well, they've got plenty of straw in their bedding, we're teaching them then to do more bed eating behaviours. So wherever possible, making sure that that is a different space within the calf shed is important. So finally then, just touching on this cleaning, which is my sort of bugbear, I think, in case you haven't got that by the end of this presentation. So this idea of really all in, all out system, and remove all that organic material. So remove all the muck and then steam clean, making sure we are using a product for what we are allowed within our milk contract particularly. So that's one to check from the crypto and Coxie point of view. But equally making sure that we are mixing it correctly and giving that the correct contact time. So that's the essential bit from a cleaning point of view.
Perfect, thank you, Kat.
Okay, and I
sorry.
I was going to say, I think that's my slides done. So yeah, over to you, Claire.
Yeah, I'll just cover now the housing essentials, but with a real focus on ventilation and positive pressure tube systems. I've firstly included this slide, which is taken from Dr. Terry Olver in the US, and it just sums beautifully actually what Kat was saying, this holistic approach to respiratory disease, and actually how many risk factors there are and how small gains can really make for big wins. When you think of optimizing calf health, welfare and production, I like to think of this multifactorial triangle. So you've got that calf with that colostrum management, that immunity, that nutrition side. What pathogens is that calf up against? And then you've got that environment, and these are the same 5 key points. And whenever I'm looking at optimizing the environment, I like to look at these. So you've got that moisture, the temperature, that fresh air and airspeed, and then that hygiene. And it's that fresh air and airspeed that we're going to focus on today. Before though, I'm just going to go over some of the key aspects to think about when you're doing your calf housing, whether it's building a new one or retrofitting with your old one. That spatial allowance for the calves, like Kat said, it's so important, and you are looking about 2.5. At the Dairyland Initiative, I think they go up to 3.2 meters squared per calf. If your stocking density doubles in your building, you're looking that you to increase your ventilation by 10-fold to keep that same air quality. And actually, stocking density is the single most determinant of air quality. That temperature, making sure you've got good drainage, and focusing on that all-in, all-out system. So actually having calves working up a building really doesn't work. You want them to go into that pen and out, and so that's not, and so that one group stays the same. And actually I'd say that maximum age range, which I know can be difficult sometimes, but between groups, probably around 3 weeks max. Sometimes you can stretch it a bit further, but I'd say that 3-week mark for age differences in groups. And then that natural ventilation supplemented with positive pressure tube ventilation. So what is ventilation? Ventilation is the precision of fresh air into the building space. So this displaces pathogens, noxious gases, heat and moisture. So most bacteria, viruses and fungi are found on dust particles and small water droplets. So proper ventilation will dilute and remove these airborne contaminants. And actually it's constantly thinking about that out with the new and in with the old. And it's the constant supply of fresh air at calf level that you're wanting. Also, when your moisture increases in your building, your bacterial survival rates will increase. And actually at a higher humidity level, the droplets of water are smaller. So that allows for deeper penetration into the lungs. When you're thinking about measuring ventilation rate, you're thinking about the air changes per hour. And this is quite a simple and easy way to look at it. So this is actually from calves and all the way through to older stock, but your minimum ventilation rate is that 4 to 8 air changes per hour. So 4 is the absolute minimum that air needs to be replaced in that building, and that's for the colder weather. And then when you're actually getting to hotter weather, you're looking you want to get up to 30 to 60 air changes per hour. And that's where actually being able to open up your buildings can really help to achieve those air exchanges. This quote by Dr. Nigel Cook from the US sums it up brilliantly. And it's actually, when a virus is coughed up in a building, it can remain there for 20 hours. But if it's coughed up in fresh air, you're looking at it for 20 minutes. And I always like to think of COVID for that, to relate it back. And so actually pathogens are killed 10 to 20 times faster in fresh, clean air. So what are the different types of ventilation systems for calves? You've got natural ventilation, positive pressure, negative pressure. However, negative pressure I don't think works when you're looking at calves due to numerous amount of reasons, but you're managing those small inlets and trying to stop drafts. You need a good air velocity requirements coming in to achieve the air exchanges in that building. Calf placement, so calves placed near the gaps where the air is being drawn in, actually they could be getting higher air speeds and having drafts, but actually calves at the further end of the building, they won't be getting any clean air at all. So you don't get that consistency through the building. Barriers in the building will restrict airflow, and there's limited research for the cooling aspect in the summer. And it's something that we don't think about. We think about it a lot with dairy cows and older stock, but calves do get heat stress too. So it's important to look at your housing and look at where you can open your buildings up to get those air exchanges in the summer. So what is recommended? You're looking to optimize your natural ventilation, and then it's that supplementation with positive pressure. We'll first go over some good principles of natural ventilation and then look at why it's important to supplement. So natural ventilation works by thermal buoyancy. So the animals generate this heat that rises and escapes through the ridge. So warm air is less dense and it ascends, cooler air descends. And this kind of establishes a natural airflow pattern, which is driven by temperature differences. You've also got the wind coming across the building. So you've got it entering, gusting through the building, and also drawing over the ridge, accelerating, causing almost a suction effect. However, do calves generate enough heat for this thermal buoyancy? And no, they don't generate enough heat to cause this natural airflow movement. And so this is where the supplementation with positive pressure is really effective. And actually later on, I'll show you how it can work. But first, let's think about the requirements of natural ventilation. So you've got to have an outlet, which is really often overlooked, an inlet, which is your sidewalls, roof design. This can help aid air movement, no wind shadows. So that's buildings blocking natural ventilation across your calf building, and then the position of the building. So firstly, your outlet, this is your ridge, and this is commonly overlooked for Youngstock housing because they don't generate this natural thermal buoyancy. However, it is still vital that you do have it, and it is that exhaust for that dirty, contaminated warm air. And for a minimum requirement, you're looking at about 0.04 meters per squared for up to about 100 kilograms of calf. And then different types of ridges. You've got this cranked ridge. This is really commonly seen in the UK. However, it's only really the 20% of the required opening needed. And actually, when you smoke a building, you're wanting, especially on a still day, that smoke to rise up and escape through the ridge. And actually, when you smoke a cranked ridge, it rises up and it skips, doesn't actually go out through the ridge, it skips under, and then it's going back down on the animals. You've got this open ridge, which is capped, and these sideboards create almost a suction effect. So as the wind passes over, you're creating a positive and negative pressure, which helps suck that air out the building. And then you've also got a light ridge, which is really important for getting even distribution of lighting down the building as well. But really, when you're thinking about your ridge, you want a sufficient opening, but you also don't want to let that moisture in the building either. So actually just opening the building completely isn't always the best way to do it. You've then got your inlet. This is your side walls, so how much air is being allowed into the building, and these need to be twice as big as your outlet. Commonly used in the UK, we have boarding. So there is a difference between your Yorkshire boarding and your space boarding, even though everyone seems to call it the same name. But your space boarding is quite simply just boards next to each other and next to each other, whereas your Yorkshire boarding is alternative on each side, which actually just helps control that wind speed and moisture into the building. You've then got side curtains, and these are going on new calf buildings a lot more now, but it does give you that option to open that building up in the summer and get those air exchanges needed. You can have them controlled automatically, so that's looking at controlled for your rain, your wind. They can open and close depending on what the weather's doing. And you can change the fabric on the curtains to have more to have a meshy one, but actually for Youngstock I'd always have solid, and it's actually that movement to let the air in and out. It's also important to have about a 2-foot wall, and that just stops that air coming in and causing a draft at calf height. Your roof design, so a slope steeper than 14 degrees is acceptable. However, actually you want to look for about 18.5 or above to really aid that air movement. When you're thinking about material, fibre cement's quite common and probably the preferred material, as it reduces condensation and also can help stable those temperature differences in the winter. When you're looking at tin roofing here, actually it gets really hot in the summer and you've got a lot of condensation during the winter. Roof lights, you're wanting about 10 to 15% on the building, with about 20% on the north face of the roof. And actually you want to avoid those hot spots in the summer, so you don't want that heat coming through and causing hot spots in the building. Polytunnels are quite a cost-effective calf housing, and they are commonly used. The trouble is they've not got an exhaust, but the shape of them does aid air movement really well. And actually the other thing is they can heat up in the summer because there's nowhere for that hot, dirty air to escape, and they aren't very good for temperature regulation in the winter. Just quickly on lighting, it's often overlooked, but lighting is really important for hormone function, and actually it will help increase weight gains. And think about where that calf naturally comes from, and actually you want to try and replicate that in your building. So you want about 16 to 18 hours of at least 200 lux level. Often I go into calf buildings and they are a lot darker and dingier than that. So supplementation with lights can be really effective. And then you want that darker levels as well. Space between buildings. This is often seen, especially in older stock, where you've got one building and then you put your next building up next to it and the one further over. But actually, if your prevailing wind's coming from this side, this building's getting fresh air into it, but by the time you get to this building, you're actually just got contaminated air coming through. And so you want to look for about 30 meters from one building to another. And another thing that's really overlooked in calf housing is where to place the building. So if you're looking on this farm, your prevailing wind's coming from this area. So actually you want, if you're going to place a calf building anywhere, you'd want to put it upwind of the farm. So if you put it over here or over here, that air is getting contaminated by the older stock and then going into your calf building. And this is particularly important for those pre-weaned calves. Building orientation. This is commonly overlooked, and I go on farm a lot and see buildings they've got great natural ventilation principles, but actually because of the way that they're positioned, it's not working correctly. So you want the wind to come over the ridge this way, and as it comes up and over, it accelerates and it creates that suction effect out of the ridge, but also passes through the building, and this allows for more of an even distribution of air through the building. However, often buildings are placed where the prevailing wind is in alignment with the ridge. So you don't have that air speed going over the top of the building, so your ridge is ineffective. But also this area of the building, if this end is open, will get fresh air in, but actually when you get up here, you're looking at quite still, stagnant air. Another little tip is you may think having this little walkway at the back of calf buildings is a waste of space, but actually in the winter when the cold air can come through gaps in your inlet, it will drop down onto the calves, and so causing drafts and cold air within the pen. So actually just positioning it about 3 foot away from the inlet can be really effective. And actually here, this farm, the prevailing wind was coming through this spaceboarding and dropping right onto the calves. So I just suggested here, if you just put some boarding up and almost created a microclimate underneath, it just stops that cold air dropping in. However, it's not just about ventilating the building, it's about ventilating the animal's microclimate. And this is particularly important for calf housing, especially when they're kept in individual housing or in group pens with solid partitions. So where did positive pressure tube ventilation come from? Well, it came from a study that looked at respiratory disease in naturally ventilated calf buildings. And the study showed lower respiratory disease with lower airborne bacterial counts in pens. The co-founding finding was that solid panels between calves to stop that nose-to-nose contact actually was associated with increased airborne bacterial counts, but lower risk of respiratory disease. So this stimulated the work to create positive pressure to get in between those barriers. And it's been adopted by dairy farmers globally. And actually the typical comment is it can reduce pneumonia treatments by between 25 to 75%. So what is positive pressure tube? So due to the inability to control that natural ventilation, so that speed and direction and ventilating that calf's microclimate effectively, this is where positive pressure can be supplemented, and you're ensuring optimal ventilation year round, and it's those minimal air exchanges that need to take place. And so it's a self-contained system. So you've got your fan on one end and then your tube along the building. Your fan should be on external to the building and it draws in fresh air, and then your tube distributes the air along the building. And there is typical comment that this system will pay back just under 2 years based on a 10% case reduction. It's important that these supplement natural ventilation, so you don't forget about those natural ventilation principles, because actually these require your basic air exchanges for your winter, so 4 to 8 depending on how the system's made, but actually in the summer you want to open that building up and get that 60 air exchanges needed. And also these need to run 24/7, 365, so they need to run all the time. So a bit about positive pressure. Like I said earlier, this is where your tube will bring the fresh air in, pushing that fresh air down to calf height, which will then encourage that heat, little bit of heat that the calves generate to go push up and exhaust through the ridge or exhaust through open eaves or outlets. And things to think about is your fan position. That fan on the tube should be drawing clean, fresh air from the outside. So it shouldn't be placed in the building, and it's important to remember that air speed doesn't mean good ventilation. You want that fan to be getting the cleanest air possible, so not by an older stock shed and not by your slurry pit. The hole size, this will determine how far the air is thrown and the air speed at which the air is being delivered at. So if the holes are too big, you'll be creating a draft down at calf level. Finally, your tube size, this makes for even distribution of air throughout the building. And it's really important that each system is measured and made bespokely for the building in order to get these things controlled. And it's mainly from an air speed and air changes point. So this picture here, you've got fans. One, this isn't bringing clean, fresh air into the building, but also this is creating high air speeds down at calf level. And actually what we were finding here is that calves would sit round the edge of the building to get away from those higher air speeds. So when you're looking at your air speeds, you're looking at about between 2 meters a second to 2.5 in the winter, and that's delivered at calf height. In the summer, you can go up to 1.3, depending on the weather. And that is at calf height from bedding. So how do we know if these systems are working? The easiest way to do it is to put smoke down the tube, and it's a great visual representation of what the air's doing, how it's coming in and out the building. But as long as it's providing that minimal air changes per hour, so that's minimal 4, but it will depend on your geographical location, whether you can have a tube made for 6 or 8. The air is not restricted at the fan. The tube is sized for the fan capacity, so the tube's not fluttering, and there's even air distribution along the building. And then the air jets are aimed towards the calf building. So from here, you can see the air comes out at a higher airspeed, it slows down, and then it's getting down into those calf microclimates. And then that hot, dirty air is being pushed out through open eaves here, or back up through the bridge. But that's a real simple and effective way to see if those systems are working effectively. And finally, I know Kat did pass on this, but temperature. Calves are extremely vulnerable to cold temperatures, and when you've got a well-ventilated building, in cold weather, that building will also be cold. So look at those nesting scores. You want a nesting score of 3. If you don't want to put that much straw in and you get a nesting score of about 2, supplement with calf jackets, and that will bring you up to a 3. But the most effective thermal support for Youngstock housing is heat lamps, and a study by Nottingham found this was the best direct correlation with improved weight gains. Finally, internal materials. Concrete is cold and will draw heat out of the calf, so actually some sort of material that will just maintain that heat and won't suck it away from the calves is vital. Thank you very much, and if you have any questions, please pop them in the chat. But if you'd like to contact me or need any advice on your calf housing, please do. Thank you very much. I think I'll stop sharing. And I'm not sure if we have any questions in the chat. But there's none come in yet, but if you do have any questions, please pop them in. We've got 10 minutes.
Yeah, feel free to put them in the chat. One interesting one that I often get is people thinking, oh, well, it's the summer now, so maybe we don't need to maybe put some the vaccinations in place, or we can turn off the fan. But I think, as Chloe hinted at, that actually as we get into the summer, maybe with heat stress, we've got other things to be worrying about. And also it is often that dampness of the air, which is a massive conflicting factor. So I think that's often where we see the challenges, but actually improving that ventilation can draw that moist, damp air away as well, so it can achieve more than one thing at a time.
I'll just leave that up just as a hatch. Please can you send us your email address. But how can we test speed of airflow? So you can have an anemometer that then you can get relatively cheap ones off Amazon, and that will just look at that airspeed coming in the building. Another great way is if you do smoke test it and you can see that air movement around the building, and actually if it's getting drafted across pens or going too quickly, that might be an indication that actually that airspeed through the building is going a bit too quick. So we mentioned heat lamps. At what age and temperature do you recommend them?
Do you want me to take that one?
Yeah.
So the figures I put on the slides there of the lower critical temperature were at birth. They do decrease by approximately 1 degree a day. So if we're thinking of the average Holstein being 15 degrees, then by 2 weeks it is down to 0. So really it's that first 2 weeks of age is really vital. Up to 4 weeks, we will see improvement on growth rates if we put in that extra source of energy. But that's really the crucial time. And that's one of the challenges, again, with coats is really we want to be taking them off in the day and putting them on at night, if you think about actually how we would do it and how the animal needs that temperature to be controlled, which is one of the problems. Whereas if you go with the heaters that are on sort of temperature switches, then that can help both from an energy point of view and also, you know, from a sustainability point of view. But what you will see when you do put the heaters in it, the calves will choose themselves, particularly within larger group pens. You'll see that they'll often cluster under it at certain times, and then other times they'll move away. But it's that first 2 weeks that's really crucial.
And then we just had another question come in of what's the maximum age range you would recommend between weaned calf groups?
Okay, so weaned, it is less of a challenge because often it's the scour in that first 4 weeks of life, which is why we're saying sort of 2-week age ranges for the pre-weaned calf. When we get to the post-weaned calf, we're really thinking ideally within a month. But obviously, as we get up through the ages, these can group even more. So then you think of other options of why we'd want to group. So, or why we can't group, which is maybe nutritional things. There's big changes happening to the calf around that 6 months of age of how they can digest, particularly the grass silages. So I think between weaning and 6 months, really we're looking at about a month age range between the groups, and over 6 months I'm not as worried. It's often more down to your housing design and stocking density. So hopefully that answers that one.
And then the ideal roof pitch for the calf building. So I mentioned, 18.5 or more is ideal just to promote that natural airflow in the building. And especially once you've got your positive pressure systems in, that will really aid that movement of that hot air, dirty air out of the ridge, especially when there's no wind movement on quite a still day. That's all the questions we've got so far. We've got time for a few more if anyone's got any.
Yeah, so feel free to put some more in the chat. Also, Chloe, when you're thinking about the roof pitch, it's often that height of where the tube can go. I think it's worth maybe discussing that both from a practical point of view of if we are having tractors in sheds, but equally how that can limit what we want the air to actually be doing.
Yeah. Yeah, that's a good point about the height at which you pop your tube in, and that's why it's important to actually get them measured and made for the building. Because if you do actually need to put it slightly higher to get machinery in the building, you still need that fresh air being delivered at calf height at that controlled airspeed. And then if it has to go slightly lower, if you've got a lower roof, not drafting the calves as well.
Which I guess does lead into, I think it was Charlie's question of an ideal height to the eaves. Do you have any points on that, Chloe?
I think it does massively depend on the size of your building and the width of your building as to your how big your eaves are going to be. So I don't have any figures off the top of my head. But yeah, it depends on that width that individual building could be. Do you see anything like that, Kat?
Yeah, no, it is often a challenge. I think a lot of that is the idea that if we bring it down, then that hot air will go out through the exhaust better. But then you sort of, it's difficult to build those sheds, and maybe if you're going for that design, it is maybe more the monopitch ideal, which again is really important where you're going to place them and how wide those sheds can be. We've just had a question in saying that we house the calves in the same pen from day 8 to 70, so when could we clean out? It is really difficult in these systems where often they're in individual or paired for that first week of life to really get them drinking and get that colostrum in, you know, be able to do that more individual care until they're drinking and then move them into a system. And if we only have one group between day 8 and day 70, that pen will often never get a break equally, because as you maybe wean out the oldest 5, and other ones will always be coming through the system. So it is a bit of a nightmare when you're thinking it from a parasite and pathogen point of view. So making sure that we do empty all calves out and do a deep clean, I would say at least monthly, if that is achievable. That would be where I would start, but it would depend on your disease challenges on your farm and also how resilient those calves are. So if we are putting lots of nutrition in, we are putting lots of straw into those pens, they are getting, you know, the top maybe vaccines or preventative care that we can give them. It's surprising what they can deal with, but if we can improve the hygiene there, we might get even better results. So it's a bit of, it depends on what you expect your calves to do from a growth rate point of view and what you're prepared to put into the system as well. Yeah, and getting that 2-week rest, that is ideal. It's really hard to achieve, but definitely when we're thinking of systems, that 2-week rest is one of the few things that's more guaranteed to try and have that higher kill rate from a crypto point of view. So that's where I would be wanting to head towards if we can achieve that.
Yeah, and it's that just as soon as that animal's out the pen, getting that pen clean straight away if you are tight on space. So it leaves with that maximum amount of time. Yeah,
definitely. As soon as the calves are out, we need to be mucking it out, pressure washing or steam cleaning, and then just leaving it. So instead of going, oh, right, phew, we've moved the calves, we'll leave the muck in there, and then that panic of, oh, we need that pen tomorrow, trying to get that mindset of actually that rest period whenever possible.
Thank you very much, everyone, for joining. We'll leave it there. And if you do have any more questions, please feel free to give me a call or an email, and I can then always pass them on to Kat that way. So thank you very much. And yeah, this will be recorded, so we'll send it out to your emails.